She's off the grid right now. It happens. All right, let's take a look at this one. So it says let f of x equal 5x to the fourth. G of x is e to the 2x plus x. And then they tell me that h is defined by that composition, f of g of x. So which gives the correct expression for h prime? I think it's interesting that there's equality in these, and I think that's just to confuse you. All right, that's all that was for, was to confuse you. But basically, they're showing you the chain rule and then plugging it in and showing what it would be equivalent to. And so our outside function, if we think chain rule, remember its definition is f prime at g of x times g prime at x. So that's really the expression we're looking for, which would be C? Yep. Okay, so, yep. That's what we're doing. It's an AP style question, trying to freak you out a little bit. So the outside function being 5x to the fourth, so that would give me 20-something to the third. Oh, maybe that's... And then we would plug in and then do the derivative. Not me. Laura's here. All right. Okay. Give them both. Okay, got it. This little guy wouldn't give me your picture on Friday.
Oh, yeah.
Today you let me keep somebody else's. Yeah, he's a nice guy. All right. So, all right, question about that one. And then, of course, if we did the derivative of e to the 2x, that's also going to be chain rule. So that's why you have 2 e to the 2x down here and then plus 1. All right, so it would be C. All right, let's take a look at our affirmation. Our strength grows out of our weakness. There we go. Okay. So let's jump in today. I want to look at these AP style questions. What are the different ways they can assess you on chain rule? Tomorrow we're going to look at some that are in an activity where the algebra is ghastly. All right. It's just the nicest way I know to explain it. Okay. Just because you're going to see it, and I don't want you to be surprised when you see it. All right. So I think it's better that we play with it a little bit in a friendly environment before, we get hostile. So what's the chain rule in words? We just wrote down the symbols a while ago. What do we do when we do the chain rule in words? Derivative of, of outside function. Evaluated at the inside. Bars. The derivative of the inside. That's what I meant. Bless you. Take your vitamin C. There's lots of germs going around. I'm not sure if that helps or not, but I'm just, it felt like the right thing to say.
Take every vitamin. Why not?
Extra vitamins. Lots of rest, lots of fluids.
Lots of rest.
Yeah, I know. It's an anomaly, isn't it?
I went to sleep at 1 a.m.
Okay, y'all. I went to bed at 8:30 last night.
At 1 a.m. Woke up at like 6:15.
And I was sound asleep by 9:15.
I never went to sleep. Time literally skipped. I didn't process my sleep at all.
It was 6:15.
Youth is wasted on the young. That's all I'm going to say.
And then that's never happened.
Yeah. Are you an early riser, though? Yeah, me too. But now I could sleep all day. Given the option, my favorite thing is to get up, eat breakfast, go back to bed, and sleep half the day. I know that's weird, but that has always been my favorite way to exist. All right. So let's take a look at some examples, okay? So I'm going to play a little bit, and then we're going to write it. We're going to do all the things. So take a look at this one. So it says to find the slope of the line tangent to the curve y equals sine cubed at the point where x equals pi over 3, and write the equation of the tangent line. Okay? So this problem, this tangent line problem, it just never really goes away. Okay? It just continues to show up over and over and over and over again. So let's talk about what we would need. We're going to find the slope of the tangent. So what's the slope of the tangent? The same thing as. The derivative. So we need y prime, and then we want to evaluate it at pi over 3, okay? And then when we write the equation of the tangent line, we need its slope, and we need a point, okay? So go.
I doubt your people would just have us floating along.
Are you in Adam's family? No, okay.
Doing musical direction for it, but.
All fine. That'll be an interesting role.
Not on stage, which is what I prefer. So.
Okay.
When it comes to acting.
Parker, you would make a great character.
I probably would. I wanted, if I was going to do it, I was going to be Mal, but
Okay.
when it comes to acting, I'm an off-stage person.
Okay.
I'm always acting.
Yeah, I've heard your method acting.
Thank you. Oh, God. Oh, God. Booyah.
What time did y'all get done last night, Oakley? What time did y'all get done last night?
Yeah, you're right.
Probably 8.
That's not bad.
Yeah.
Times 3.
That little video Greta made was cute.
Oh, yeah.
Let me draft it in my brain, and then I'll go over the refined version. 304.
I mean, Samuel, I've got full pieces of paper back there if you'd like. Okay. I'm like, he's writing on a shout out form. I'm like, I got full pieces of paper.
Wait, was it one of your shouts? Yeah.
He's not going to be about killing any extra trees.
No, they're already dead.
Yeah, it's already dead, so why kill another one?
We're not making the trees alive.
Gotcha. I'm fair. It's fair. All right, so let's start with the derivative, okay? So sine cubed of x, is it going to require the chain rule? Yes, okay. My outside function is going to be 3 and then something to the second. Well, that something is going to be sine. And then what's the derivative of sine? Cosine. So that's actually the derivative, okay? So if we miss that, it was all downhill, okay? So we had to get that part right, all right? So now let's evaluate y prime at pi over 3. It's going to be 3 times the sine at pi over 3. We're going to square it times the cosine at pi over 3. All right, a little bit of arithmetic here. Sine at pi over 3 is square root of 3 over 2. And we're going to square that. Cosine at pi over 3 is 1/2. So 3 times 3/4 times a half gives me a slope of 9/8. Okay, so that was the first thing it asked for. What is the slope of the tangent line? All right. Now, in order to write the equation of the tangent line, we need an ordered pair. Well, I know my x value is pi/3, so let's plug that into the original function. So I need the sine at pi/3, but I need to cube it. Okay, well, that's square root of 3/2 3 times. Okay, so just to help you a little bit with that. Okay, so that's going to give me 3 square roots of 3/8. Okay, so 3 square roots of 3. Now we can write the tangent equation. Okay, remember any equation of a line you write must start y equals. So my slope 9/8, x minus pi/3, and then plus 3 square root of 3/8. And that is definitely one I'm not simplifying. Okay. Where were your issues with that one? Chain rule. All right, chain rule.
This is my point. This is 1 point.
Mm. He's a booger. No, that's why we spend several days making sure we get it. You'll beat it. You will. You'll eventually get it. Okay. All right, take a look at this next one. All right. And I labeled this one creativity and simplification because I'm going to show you a little trick that's going to help us simplify some things here. But let's take a look at that function. Notice the notation's a little different, okay? They have that d dx, and then we have the whole big function. So let's talk for a second about what that function includes. All right, I've got an x cubed times something to the 4th power, right? So this is actually going to use 2 big rules for us, all right? The first one it's going to use is the product rule, all right? Because I've got x cubed times something to the 4th, okay? So I got a product rule. And then when I do the derivative of that second piece, it's going to require the chain rule, all right? So recognizing that in the process. So let's do that. So my derivative, all right. Oh, I don't know what just happened there. Undo. Undo it again. One more time. I don't want that. Okay. So if we for freaking Nugan. All right, here we go. So first, times derivative of the second. Well, the derivative of the second is where my chain rule is going to happen. So 4, 3x plus 2 to the 3rd. And then times the derivative of that inside, which would just be 3. Okay. Plus second, so 3x plus 2 to the 4th, times derivative of the first, which would be 3x squared. Now, this is where I'm going to do some creative simplification. Basically, what I'm going to do is take everything that's not in a parenthesis and multiply it together. Okay. So a 3, a 4, and an x cubed is going to give me 12x cubed, and then 3x plus 2 to the 3rd. Plus, on the other side, I've just got a 3x squared and a 3x plus 2 to the 4th. Oh, went backwards. Okay. Now, the reason I wrote it that way is because I wanted you to see it looks a lot like factoring kind of by grouping, okay, in terms of simplification. We're looking for a common term, okay? Start with what's outside the parentheses, okay? A 12x cubed and a 3x squared. What could you pull out of both of those, just those pieces? A 3x squared. So let's do that, okay? And if you'll notice, they both also have a 3x plus 2 to some power, okay? So we can take out a 3x plus 2 term as well, all right? Which one would we take out? 3x plus 2 to the third, okay? So those are common as well, all right? So now when we simplify, let's talk about what would be left. 12x cubed, if I took away a 3x squared, what would it leave me with? A 4x. A 3x plus 2 cubed, but I took the whole thing, so that goes totally away. On the next term, 3x squared, but I pulled out the 3x squared. And then I have 3x plus 2 to the fourth, but I pulled out a 3x plus 2 to the third. What does it leave me with? A 3x plus 2, okay? So the most factored version of this expression is this: 3x squared, 3x plus 2 cubed, 7x plus 2. Now, I showed you that on purpose because you're going to need it for the activity tomorrow. All right? They do a lot of that kind of factoring and simplification, right? Where they look for common terms and pull things out. Where it gets really gross is when they do it with negative exponents. Yeah, okay? So take a second, digest that. Ask me a question, all right? That's just creative algebra right there, all right? The calculus was the first line, which y'all all did beautifully, okay? It's the algebra after where it got gross, okay?
Are you going to show us some negative?
I don't believe there's one in here today, but there might be one in,
I want to go with compare.
yeah, you'll be ready.
Give us a quiz today or not.
That's right, I am giving you a quiz today. I'm not here.
I'm not here right now.
It's not a Monday, it's Wednesday.
Oh. Oh, you say you were giving us a quiz today.
Oh, Lord, no. No, not today.
Not today.
There it is. You looked at the calendar, Samuel. I'm so proud of you.
Yay.
I may take my notes on the shout out form, but I know when the quizzes are. All right. Okay. Y'all are funny. All right. Okay. Well, you know, it wouldn't be AP if I didn't throw you something with a table. Okay? AP questions, they love a good table.
Honestly, tables are easier than doing the algebra.
Okay? They love a good table question.
F would be better.
All right? You can count on it. So let's look at this. We got F, we got G. They give me certain values at certain values of X. And they want us to evaluate the following derivatives with respect to X. And so here's the first one, F of G of X at X equals 2. So let's walk through that one, okay? It's composition. And this is just knowing your chain rule. And this is when we need chain rule, all right? So derivative says we would take F prime at G of X times G prime at X. I'll just caution you. The biggest issue that I see people have with these is just not plugging in the right stuff at the right time. So it wants to do it at 2. So everywhere I have an X, I'm going to put a 2, right? And then we're just going to follow it step by step, all right? G at 2 is 2. G prime at 2 is negative 3, right? And so then when I finish, I need F prime at 2. Well, F prime at 2 is 2/3 times negative 3, which would simplify to just negative 2. So just do it a little piece at a time. Step right through it, okay? So derivative of composition, F prime at G of X times G prime. And then plug in your X value and simplify it a piece at a time. Right? Okay. Let's do the next one together as well. Okay. I'm going to actually rewrite that function to start. Because the square root of f of x, would you agree that that's f of x to the 1/2? Yep. Okay. So does it require the chain rule? Yeah, it sure does. Okay. okay? It does. So we're going to take 1/2 times f of x to what power? -1/2. Good. Times the derivative of the inside. Well, the derivative of the inside is just f prime. Okay, because I don't know what f is. Now let's plug in the 3. So I want 1/2 times f of 3 to the -1/2 times f prime at 3. Right. Piece at a time. How much is f at 3? It's 3. Okay, to the -1/2. F prime at 3 is 2 pi. And now we're going to do some simplification. Okay, 3 to the -1/2 is 1 over, so I got a 1/2 times 1 over the square root of 3 times 2 pi. Right? Anything going to simplify? Yeah, the 2's are going to cancel or reduce. And so I get pi over the square root of 3, and we're going to leave it that way. Okay. So you get some unique answers with these sometimes. All right, just because they have values that don't simplify. We do not have to rationalize, which is nice. Okay, we do not have to rationalize. All right. Got a question, Jawak? Giving me the dark eyebrow over there.
I used to, I was thinking if I remember now,
Multiply by square root of 3 over square root of 3.
Oh, okay.
Mm-hmm. What'd you say, Laura? We rationalized last year. In pre-cal we have to, but not in calculus. I'm not sure why.
Simple, but our answers are ours. It's just like,
Yep. All right, y'all try that one.
I got bitten by a dog.
You did?
Yeah.
Your dog or somebody else's dog?
It was someone else's dog.
Okay.
A terrier mix. Yeah, like pit bull, basically. I didn't provoke it, but I was petting it behind the ears, and it looked sweet, so I went like
You
this
leaned in to
it,
get a kiss. Yeah.
and it
It disagreed.
Yeah.
Well, that's what happened to Rebecca with our own dog. Like, she leaned in when he was still asleep and he bit her
I
face.
did scream. I went like that, but yeah, it kind of hurt a little.
kind of hurt.
Did it bleed? Yeah, a lot. Like there was I was driving home and there was like blood down my seatbelt.
That's cool.
Small dogs especially have need for blood.
But
That's the one thing I'll say about our pity is that he will definitely tell you if he doesn't like something. Like if he goes, "Ugh," you just stop it. He doesn't want that.
yeah, that was the thing though. It didn't growl once.
It didn't.
It was an 11-year-old dog, and they said
Oh.
they'd never done anything like that.
Yeah.
before.
Well, sometimes they're just grumpy.
Yeah.
I'm just kidding.
Old dogs, my beagle's that way. Like last night I was trying to look at his feet. He's just old and grumpy. And I touched it. He went, "Meow." And I was like, you know, he wouldn't intentionally bite me, but he was like, leave me alone.
Yeah.
Yeah.
If the dog weighs less than a quarter of me, it's not, no.
Yeah. Our beagle's way overweight, but that's okay. His head just looks so little for his big old fat body.
It's like, baby, my dog, is like this big.
Mm-hmm.
Half my weight. 'Cause she's,
Yeah.
she's so sweet.
I know. Now that I've had a pity, though, I would have them all. Like, I want to rescue all the pity mixes. Because I see, because he's just so lovey, his big old bucket head. I just want to squeeze it. Anyway. Sorry. I told my husband if something ever happened to him, just know I would have a house full of dogs before I'd have another husband. The bed will be full. I said, I will rescue all the animals. They will all live with me. The house will smell bad. Like, I'll be that woman. So, just know.
Crazy dog.
I'll be the crazy dog lady. I want them all, especially the old dogs. And, people, things happen, and like they're older dogs and they get just abandoned sometimes. And it's like, I just feel so sorry for them when they land because nobody wants to adopt an old dog.
Maybe you can take the one that bit me.
Yeah. We can't have any more until our current two are no longer with us because they are rotten. And it's all my fault. It's okay though. All right. Your hair still looks good though. Did you? Okay. So let's see how we did. Definitely chain rule, right? Because we got cosine of a function. So if we go through here and we do our derivative, h prime at x, well, what's the derivative of cosine? Negative sine of f of x times f prime at x, okay? And then we want to evaluate at 1, so h prime at 1, so the opposite of the sine of f at 1 times f prime at 1. And we're going to pull all of this from the table. So here we go. F at 1 is pi over 6. F prime at 1 is 4 square roots of 3. Okay. So what is the sine at pi over 6? 1/2, but we want the opposite, so negative 1/2 times 4 square roots of 3, which would simplify to negative 2 square roots of 3. Okay. How'd you do? Excellent. Okay.
One thing I don't understand.
Yes, ma'am.
I just don't, it's not like even a math thing. It's why when you multiply something that has a number and then a square root, something like that, why does it only multiply in the first?
Because that root is not just what's underneath there. Like you have to understand if I took it out of the root, it's double that. So they're not like terms. Yeah, a radical is a different type of term than just a coefficient. Okay. All right, here we go. Try this one. The one at the top that I can't get my Zoom to work. There we go. All right, there you go.
It's not, but I'll.
We're going to actually do 2 real free response questions today, by the way.
It's not.
Ooh, like it.
I was bored, the 3D printer wasn't doing anything, so I heard.
Oh, that's cool.
And of course, I showed it to people at thing Saturday, and then someone already is getting to print one and then Uber password.
May I?
It's a dragon.
He's not supposed to
Maybe we'll
distribute.
throw it.
I am.
I can put whatever I want.
I'm dragging the dragon.
Becca made me a jewelry holder.
Hold it by his
That was one of her classes at Tech they had to do in educational technology. And it was learning how to use 3D printer and all that. Mine, when I took it, was how to laminate. How to make a video with a camcorder.
Or these are things you need to know.
Yep, how to use a paper cutter. Like, y'all, I just cannot. It really was. Makes me laugh now when I think about it. Like, my computer class was like, we had to buy those hard floppy disks that go in the old Apple computers. I still have all of mine. I threw away a couple just because, it was time. But I kept them forever. Yeah, that's how old I am. It's okay. I am ancient at this point. You can call me an antique.
The oldest thing I've seen you do is you just sit there and zoom your iPad like that.
Oh, with 2 fingers.
2 hands.
Sorry. Sorry, Gareth. I always wonder, like, will I retire before the technology outgrows me or vice versa? Yeah, I'm doing the best I can. I've just started texting with 2 fingers because I used to be a 1-finger texter.
Now you need to advance to swipe texture.
I use 2 thumbs to text now.
I just,
Sorry.
Have you tried your
Now
damage
you need
designing stuff?
to advance to the.
I can design like functional things, not.
The swipe texting?
Not these.
Okay, I'll learn. I'll try to learn.
It's faster,
Okay.
but also you typo more.
Oh, that's not good.
It's judging on auto.
Because I told my vet I was going to lick my dog up, so that's not good. Instead of pick my dog up. Okay.
Yeah, I tried to split it once and I was like, what is that?
Oh, yeah. That's what we did.
Or 3D.
Yeah.
I got 3D, like,
All right, let's check it. So J prime, okay. What's the derivative of, or what's the outside function on this one? E to the x. So I'm going to take e to the gx times the derivative of that exponent, which is g prime, okay? And then we're going to evaluate that at 2. So j prime at 2 would be e to the g of 2 times g prime at 2. And let's see what kind of interesting things are about to happen. G at 2 is 8, so I get e to the 8th. G prime at 2 is 5, and so 5 e to the 8th. It's an exact answer, but okay, how do we do? How do we do? Okay, so I think you're feeling it, right, in terms of the table. Let me just show you the next one. We're not going to physically do these two because I want to get to the composition, to the free response, okay? But one of the things they love to do to you on the AP exam is give you a whole bunch more information than you need, all right, in hopes that you will look at it incorrectly and grab the wrong piece. All right, it's a deliberate trick. But both of these are the same. Just notice how it's questioned. This first one, find P prime at 1. It's just a normal composition. The second one, M of X equals H of F of X. So you got to pay attention to that. Notice this time the question says, what's the slope of the graph at X equals 5? This just wants to be sure that you understand you're looking for M prime at 5. Okay, so they're just asking it in a little different way, but it works the same. Okay, so now let's look at a different thing they like to do, which is to use graphs. Okay, sometimes they'll use graphs along with tables. All right, but flip it on over to the other side and let's look at this one. All right, so the graph below shows y equal h of x and y equals j of x. The solid graph, y equals h of x, consists of 2 linear pieces. The dash graph, j of x, consists of 2 linear pieces. Why do you think it's important that they told me they were linear pieces?
Because if they're not, they could be non-differential.
Right, okay. So we could have some non-differentiability there. Also, when I have a linear function, how do I find its derivative? What's true about its derivative? It's the slope, okay? It's the slope of the piece at that point, all right? So that's why they told me it was linear, so that I would be able to evaluate the derivative, okay? So they're asking me to find P prime at 1, okay? Well, here's P. So P prime of x is going to equal derivative of the outside, evaluated at the inside, times derivative of the inside. And we're still going to go in and put our x value in. So P prime at 1, so J prime at h of 1, times h prime at 1. And so I really like this question for lots of reasons, but mainly because it forces you to understand what you're looking for. Okay, so we've done the derivative now, we've done the calculus, the rest is kind of the evaluation piece. So I want J prime. First thing I have to find is H at 1. okay? That's not a slope, it's a y value, okay? So the h function is the solid function. At 1, what is its y value? 3, okay? The second thing we want to find is h prime at 1, okay? Well, that's the slope of that line when x is 1. And so if we look, what's the slope of that line? -3. 2, 3 over 1. Yep, so it's -3. All right, so we're close. We've got one more thing to evaluate, and that's j prime at 1, which happens to be the dashed line. And so if we come up and find the slope of that one at 1, what's its slope? We're doing the j, which is the dotted line. Should be 2. Oh, sorry, at 3. Sorry, that's on me. J prime at 3, let's go over there. Then yes, it is -1/3, right? Yep. So I have -1/3 times -3, which gives me +1. Okay. All right, so using those graphs, knowing when to look just at the graph itself and when to look at its slope. Okay. All righty. You good back there, Jawak? Okay. Justin, you all right? Nah. Try your best. All right, works for me. Okay. All right, let's look at number 9. Okay. So I think this is an interesting question. It says to show that the slope of every line tangent to the curve y = 1 over all of that is positive. Okay. So let's think about what we need to do to show that. Okay. So let's pick it apart. If I'm looking for the slope of every line tangent, what am I looking for? I'm looking for the derivative, okay? I'm looking for y prime, so let's start there. Okay, let's start there. The first thing I notice is I do not, under any circumstance, want to do a quotient derivative, so I'm going to pull this up as 1 minus 2x to the -3. Okay, because I want to avoid that at all costs. All right, so now doing that, let's take the derivative. Okay, so y prime is going to equal -3 times 1 minus 2x to the -4. Am I finished? No. What's the inside derivative going to be? Good. And so that simplifies to 6 over 1 minus 2x to the 4th. Okay. So now, there's my derivative. Okay. Is it true that no matter what x I put in there, I'm going to get a positive number as a result?
Yeah.
Okay, why?
It's to the 4th.
It's to the 4th power. We know the numerator's positive. As long as the denominator is always positive, a positive divided by a positive is positive, okay? So this would be our explanation, okay? Y prime represents the slope of the curve. At any point x. Okay, since the numerator is positive, and the denominator will always yield a positive. The slope will always be positive. Okay, now, it sounds like you're stating the obvious there, okay? But I think as we learned last year in pre-cal, that's kind of what we had to do on our verbal explanation, all right? We had done the mathematical work, all right? We know a positive divided by a positive is going to always be a positive, but we have to answer the question, all right? And explain the different pieces, right? So, before we finish, here's what I wanted to do. I wanted to actually take pieces of 2 free response questions. One, we could do two of the 4 parts, and then one, we could do 3 of the 4 parts. So actual release questions. And I just want to walk through them with you and talk to you about how they score them, okay? And show you that, because we're at a point where we're going to be able to see, especially on your tests and stuff, actual free response questions. And that's what I try to do. I try to pull them from released exams and things like that, so that, you know, you're getting a legit free response question, all right, so that you feel more confident when you see those for real on the test. Okay, so let's take a look at the 2012 question number 4. This is a non-calculator question, all right? So let's look at it, okay? So it says the function f is defined by, and it gives me the function. Notice it says between -5 and 5. Why does it say that? It wouldn't work otherwise, right? So they give me the domain of the function. What kind of function is that one, by the way? It's a semicircle, yep. And so the first thing we want to do is to find the derivative, okay? Is to find the derivative. So let's do it, all right? Let's do just good math and find that derivative, okay? So f prime at x, all right? Remember, f of x is the same thing as 25 minus x squared to the 1/2. Okay, so here we go. All right, let's take that derivative. All right, what's it going to give me? Mm-hmm, 1/2, 25 minus x squared to the -1/2 times -2x, okay? You can actually leave it like that, all right? You could leave it with just the pieces of the derivative. You do not have to simplify when it comes to a free response, which is nice, all right? Most of us, though, will get into a habit of we're just used to doing it, so we will, okay? And most of us would have simplified that to -x over the square root of 25 minus x squared, okay? It's all or nothing, 2 points. Okay, and every free response question is worth 9. Okay, so this piece alone is worth 2 points. So if you can do the derivative and you can do nothing else, you can still get 2 points. Okay, so I really, as I told y'all before, I really look at the free response as the bonus. It's how we get those extra points we need, all right, to make up for what we goof up on the multiple choice. Okay, and then, this is interesting, the next one, write the equation of the tangent line to the graph at x equals 3. Okay, so let's see what we need to do. We have a formula for the slope, all right? So we're going to need f prime at 3, all right? So the opposite of 3 over the square root of 25 minus 3 squared gives me -3 over the square root of 16. Or -3/4. So we know that's the slope of my tangent. Okay. Oh, is it at negative? It's at -3. Ignore me. That's going to be a plus, and a plus. Sorry. Okay. What's the other piece of information that I need for this? I need the point. Good. So the point we're going to plug back into the original function. So I need f at 3 as well. And f at 3 is just going to be the square root of 25 minus 9, or the square root of 16, which is 4. Okay, so I have my slope, which is 3/4. And I have my point, which is -3, 4. I keep forgetting that it's negative. All right. Still haven't answered the question. All right. So let's write the equation of that tangent line. My tangent line equation, y equals, you must start with y equals. Okay. My slope, 3/4, x plus or minus 3. Plus 3, and then plus 4, okay? This question was worth 2 points, all right? You get 1 point for plugging in the 3 correctly, the -3, so getting the slope right, and you get 1 point for the entire tangent equation, okay? So there, in just 2 parts, you can get almost half the points for that free response question. Okay, so not all the free response questions are terrible. You're just tired by the time you get there because you've done a whole lot of math. It's right at 3 hours, 15 minutes. Yeah, and you'll pretty much need it. Unlike pre-cal where you had way too much time. I can't remember the exact breakup, but it's like we have 6 questions. You get 30 minutes per question. On the free response, is that an hour and a half? Yes, so it's an hour and a half total. Yeah, and you get a 15-minute break. Yeah, it's something like that. I can't remember the exact breakdown between multiple choice or calculator, non-calculator. I should have it memorized, but I don't. Okay, I have to look it up every year. All right, so that wasn't too terrible, right? Yeah, okay, just pretty straightforward. Let's look at this one. Okay, so we're going to do all 3 parts this time. And there's one more part that we didn't do, but that's just because you're not ready for it yet. Okay? All right. So, okay. So let f be this function. So there's a function f, a 2x plus e to the sine x. Let g be a differentiable function. The table above gives g and its derivative. And then let h be a function whose graph consists of the 5 line segments shown in the figure below. So you're going to use all 3 representations in one problem, okay? An algebraic, a tabular, and a graphical representation, all right? Classic AP, all right? So find the slope of the line tangent to the graph of f at x equals pi. So it's specific. We're only going to use one function, which is f. Go. All right, let's see if you can do that one.
I called time and a half on this bank that I didn't turn. And I didn't even use it. I used it a little bit. Most of it was like, I went through, I got done by the time, and then there were like 3 questions I answered that. I was like, it just took me 10 minutes each, and I was like, what the heck is happening? I ran out of time.
All right, how'd you do? Cosine pi is -1. And e to the 0 is 1. That's a common mistake people make. They'll throw a 0 right there. All right, because we're so excited to see a 0, we just say 0. Okay, so it should be a -1. That was worth 2 points. Okay, so just getting that right was worth 2 points. Okay. All right, let's look at B. B's asking us about a function called k. We haven't even talked about k, but they want h of f of x. All right, so find k prime at pi. Okay, so let's walk through that one. H of f of x. So for part B, come over here. So k prime is going to equal h prime of f of x times f prime at x. Okay. All right. Let's see, f at, we're going to plug in what? Pi? Okay, I'm going to go up here and do that. So f at pi is going to equal the cosine of 2 pi plus e to the sine at pi. So cosine at 2 pi would be 1. And then e to the 0 would be 1, so we get 2. And then f prime at pi we just did, which is -1. So that's why it's important that we got that one right. Okay? Now, I will tell you that they will give you partial credit, sort of. So, like, if you make a mistake arithmetically, but you use that same answer later, they do not count it against you twice. Does that make sense? So they would compute if you did all the work right, but you had the wrong numerical value there because of the previous answer, you would still get the credit. All right, so that's at least nice there. So then h prime at 2. Okay, well, h was the graph. So how are we going to get the derivative of h at 2? We're going to look at the slope. Okay, we're going to look at the slope. So what's the slope of that piece right there? -1/3. Okay, so k prime at pi is going to equal -1/3 times -1, which would be 1/3. Okay, you actually get 2 points for this one. Okay, you get 2 points. You get 1 point for this top line, all right, for doing the derivative correctly. And then you get 1 point for the final answer. So 2 points. Okay, so this is where you would get the first point for having that. You probably wouldn't get the second point for that arithmetic mistake. All right, sometimes they do, though. It just depends on the year. Okay. All right, last one. Okay, so let m be the function defined by m of x equals g of -2x times h of x. So this time we have a composition and a product, right? And we want to evaluate at 2. So let me jump down here. Okay, so for part C, all right, m prime, let me just rewrite it first. M of x is going to equal g of -2x times h of x. So it's a product rule first, okay? So m prime says that we're going to take the first times the derivative of the second, which would be h prime, plus the second times the derivative of the first. Now be careful here, okay? What's your outside function? G. So we're going to do g prime of -2x times the derivative of the inside, which would be -2. Okay, so that's where that one gets a little convoluted. All right, and that is worth a point. Oh, it's actually worth 2 points. Okay, so that line's worth 2 points. Now we're going to actually plug in. We want m prime at 2, all right, which means I want g at -4 times h prime at 2. plus h at 2 times g prime at -4 all times -2. So lots of different values that we're going to pull from. Okay. G of 4 we're going to be able to get from the table. All right, so G at -4, was +5. Okay. H prime at 2, we already knew was -1/3. And then plus H at 2, that's just the value of the function at 2. Ooh, what's that going to be? It's a -2/3. This is where you have to use the slope. Okay, so if we think it's going down 1/3 for every 1, so at 1 down 1/3, at 2 down 2/3. Okay, so it's a -2/3, and that's tricky right there. Okay, so a -2/3. G prime at 4, we're going to grab that from the table. So G prime at -4, is -1. And then times a -2. All right, so lots of numerical values there, okay? Now, I'm hesitant to share this with you, but on the actual AP test, once you get to that green line where all the G's and H's are gone and you've got nothing but numbers, you can stop. You don't have to simplify. Okay, if it's a calculator question, they're going to ask you to simplify. You're going to need the number, but on a non-calculator, you can stop right there, okay? I never do that just because it's against my whole nature to do that, normal, but on the AP exam, they don't care, okay? Because they want your math and your time spent not in your arithmetic, they want it spent in your calculus, okay? So there you go. So if we did simplify that, though, that's -5/3 minus 4/3, which is -9/3 or -3. Okay, so they just don't want you using your time doing arithmetic. Yeah, so, but it's pretty simple. Most of us would do it. Okay, so 2 points for the first line, 1 point for the last. Okay, all right, so that gives you 5, 4, 7 points of the 9. Okay, so the last piece of that question is only worth 2 points, and it covers the theorem we're going to talk about in the next unit. Okay, so you could almost do a full free response question there. All right. Yay. All right, questions. What do you think? All right, just wanted to show you some AP style questions, what they look like. Okay. Sometimes they're in multiple choice. So almost always there's a free response that has the multiple approach view with all 3 values, all 3 forms in a free response. Not always, but almost always. Okay, so there you go. All right, so your lesson practice today, all right? It's 2 parts. There's some out of your text. Let me go get the page number for that. But there's also this 4 corners worksheet. I put some copies on the back. Do not do the analytical corner because that's the next lesson, all right? So don't do the analytical corner. But you can do the other 3, all right? And then let me find that page number because it changed. Okay. The page number is this one, page 166 to 168. And these are 4 problems, 62, 64. Most of them are, I think these are mostly tables. 78, 79. Okay. Tomorrow we're going to do an activity outside in the hallway. It's a pirate scavenger hunt just because it's fun. But it's chain rule derivatives. Okay. And Madeline's going to take her PSAT. Rocket sis. You got it. Okay. So there we go. All right. And then Wednesday when I'm not here. Okay. So tomorrow will be kind of your day to ask me questions. All right. Because the problems will be really similar to what you'll see tomorrow. and some of these AP style questions on your quiz. I can tell you in just a second how many questions it is because I already got it made out. Okay, so that I'm ready to go. I know y'all are impressed that I'm ahead.